President Engineer Amina Al-Bastaki to introduce and to welcome you and introduce our instructors. Amina, microphone with you, please.
Thank you, Engineer Omar. First, I'd like to thank our secretary to have this course and to arrange the wonderful course of the ISO 17025 general requirement for the testing and calibration laboratory. And our instructor today, he is Mr. John Barsmoley. He is head of electrical time and frequency and deputy quality manager at EMI. He has a master's degree in industrial measurement system and 30 years of experience in metrology, including 11 years at NPL UK and 9 years at EMI in UAE. He is an EAC technical assessor and a member of the ENAS Technical Advisory Committee. Welcome, Mr. John, and all the participants. So you can start. Thank you very much.
Thank you very much.
Amina.
Yes.
Thank you, Amina, for the welcoming and the introductions of our instructor. John, the floor to you right now, please.
Thank you very much to Amina and to Omar. I'll just share my presentation. Now, I can see very little, so if you need to ask me anything, it's probably best if you speak rather than raise a hand, because I don't think I'm going to see it. So this is very much just an introduction. We've got 3 hours, and so I'm not going to turn you into an assessor in 3 hours. It's not possible. All we can do is give you an introduction to the requirements of the standard and some guidance on what to look for, but we're really not going to produce assessors at the end of a 3-hour course. So this is just to get you started. So what is IEC 17025? It's the international standard for laboratories that do testing, calibration, and sampling. And what we're ensuring here is that we have requirements to ensure that the laboratories are competent, they're impartial, and they have a consistent operation. And how we do that, we specify the activities that must be included in the laboratory operations to provide the confidence in the ability to produce valid and consistent and reliable results. And it applies to all laboratories. It doesn't matter if you're independent or a government organization, or if you're a large organization or a small organization. All of that is all covered by the same standard. And it's really a very minimal set of the things you should be doing to ensure that you can consistently get the right results. What's that? Don't seem to be able to change the page. So I'm just having a little bit trouble with the advancing. It worked for the first one, but now it's stopped working. Nothing's working.
John?
Yes.
Send that. You can send us in case you are not able to fix. You can send us the presentation so we can control it from you by email.
Okay. Let me just see what's happening here. Very interesting. It works fine. I don't have the screen shared. Right. So what is ISO IEC 17025? A laboratory management system based on the 17025 standards. Make sure that laboratories have control of their quality and administrative and technical activities. And it's based broadly on the principles of ISO 9001. So that's meant that the new version, 2017, has adopted two things. One is a risk-based approach, and the other is a process approach, which is very new to the way that the standard has been laid out. And this means it's less prescriptive than it used to be in the activities and the documents that are required, but actually all of the important outcomes remain the same. So that's the change that we've recently been dealing with the new standard. How is it different from ISO 9001? Well, ISO 9001 is a generic standard for quality management systems. It can apply to anybody. It can apply to hospitals. It can apply to people who make bottled water. It can apply to industrial organizations, and it can apply to laboratories. Certification to ISO 9001 recognizes that you have an effective management system in place. So that means that you have a system and that people are following it. Accreditation is the next step up from certification. And an accredited body is one that is allowed to issue certificates. So accreditation to ISO IEC 17025 includes recognition that you have an effective management system in place and that it's followed and that it's monitored, but it also ensures that the laboratory has the technical competence to perform the calibration or tests listed in its accredited scope. And this will be very, very specific, as opposed to 9001, which can be very generic. So it's a big step from 9001 to 17025, and many quality managers who think they know all about 9001 and maybe do know 9001, when they come into laboratories, misunderstand that this is not certification, this is accreditation, and we're looking at a much higher threshold for acceptance. And we've had a number of issues in the UAE in the past where the quality managers were really not aware that accreditation and certification are very different. I'm going to talk to you about a lot of rules, a lot of abstract technical things in the next 2.5, 3 hours. But that's not what it's about. It's about customer satisfaction. What the standard lays out are the minimum requirements that a laboratory should be following to ensure that it is competently and consistently providing the right outputs to its customers, providing them with customer satisfaction. And generally, if you've got an accreditation body performing your assessments, they will be looking to perform the assessments in a way that ensures that the laboratories are providing the right service to customers. And the outcome will be customer satisfaction. So there's lots of detail, but don't ever lose track of the fact that 17025 is about quality and about customer satisfaction. We're trying to provide our customers with the right results every time. There are a lot of terms and definitions, and I'm not going to go through them all in this presentation. They can generally be found in one of the documents, either in the ISO 17025 standard itself. Some of them are in Guide 99, which is the VIM, the International Vocabulary of Metrology, also known as JCGM 200. And also, a number of them come from conformity assessment, so you'll find them in the ISO IEC 17000 document. You have to pay for ISO IEC 17000, but conveniently, most of the definitions are available online in the ISO online vocabulary, which is the link is here. So those are where you will find terms and definitions. I will talk about a few of them, but I'm generally assuming that you understand most of those terms as we go through. If not, you're going to have to look them up, or you can ask me as we go. So there's a structure 17025. This is how it goes: forward, introduction, scope, normative reference, terms and definitions. There's no requirements in those sections. There's a lot of words, a lot of explanation, but nothing you're actually required to do. Once you get to section 4, you get some general requirements. These are consistent across all of the 17,000 standards produced by Casco. Then there are structural requirements, resource requirements, and process requirements. These are the technical part of the document generally, about how you do calibrations, testing, or sampling. Section 8 has the management requirements. And then there's Annex A, which is about metrological traceability, and Annex B, which explains a little bit more about the management system options, which are in Section 8. There's also a bibliography, which is truly massive for the newest version of the standard. Previously, it's been very small, but now it has many, many documents. I have no idea if any of them are useful, but they're all there. I think if you've got the vim and the gum, there's probably not much else you need. Now, as I said, section 4 are general requirements, and these come from the Casco committee, and they're in all of the 17,000 standards. So these apply to your accreditation body. They apply to people doing ISO 9001 certification, and they apply to calibration labs. So the first one of these is impartiality. Now, impartiality is a big thing if you're an accreditation body or a certification body, because many certifications and accreditations involve a certain amount of grey area. Nothing's ever black and white. Impartiality is important for a calibration laboratory, but generally we're relying on our results to justify any decisions we make. So I don't think there are always numbers behind anything we do. And so I don't think it's a very difficult thing to meet the impartiality requirements. But it's important. You have to be impartial. You have to be perceived to be impartial so that you can provide your customer with confidence that the results that you're producing are just based on the numbers, and that there are no other reasons why you're making the decisions or reporting the things that you are. So it's very important that all of your internal and any external personnel, contractors or people who are working with you, are aware of the need for this impartiality. So as we maintain this confidence, we need to be able to demonstrate that the laboratory's decisions are not influenced by any other interests, parties, or relationships, and are only based on the results of the calibration. We're not saying you have to be independent. You can be a laboratory that's part of a manufacturing company. You can be a government laboratory working for other sections of government. We're not looking for independence. We're looking at impartiality. Those structural relationships with your company or your government should not be affecting the results that you produce on your certificates. What sort of pressures are there? Well, productivity quotas perhaps might influence people to be impartial. Pressure to retain customers to ensure financial income for the laboratory, or the effect of poor results on the parent company or customer. I don't think many of those apply to government laboratories, but you do have to be aware that there may be such influences. You look at the recent scandals with Volkswagen and their diesel cars, which were designed to meet the tests. They recognized when they were being tested and they changed their results. And that reputational damage is going to last for years. It's very quick to lose the confidence of your customers, and it's very hard to get it back. And so that's why this is very important that we follow it. What threats are there? Well, self-interest. Somebody may do something in their own interest rather than in the interest of the laboratory. So they may complete measurement results without making the measurements. It may mean that they finish quicker and they can go home or they can complete their target. So that's a self-interest issue. Self-review. If you do the work and then you review it yourself, you're never impartial. We all know that everything we do is perfect, and therefore reviewing yourself is a big impartiality issue. Familiarity or trust. We know that certain equipment from certain manufacturers or things that come from certain customers are always in good condition. They always meet their requirements. They always behave well. And that can lead you to not be sufficiently skeptical of the results you get. So you have to try and avoid things. As I say, generally we're dealing with numbers. This is not a big issue often. The other thing that could happen is some form of intimidation. So you get a result which is not good, but you are in some way threatened into changing the results that you issue. These things could happen, but they're fairly unlikely, I think, in the laboratory environment. The important thing here is that we minimize the risks. We identify them and we find some way to minimize the risks to impartiality. You can do that in part of the actions to address risks and opportunities. You can manage it as part of your risk management, which you're going to have to do anyway. Somebody has to be authorized to be responsible for minimizing that risk. And the laboratory management have to be committed to identifying and safeguarding this impartiality on a continual basis. This is not a one-off that we do once to get our accreditation. This is something that needs to be ongoing, and it needs to be part of the ongoing quality awareness in the laboratory. So we need to make sure that we understand impartiality. We're looking at it continually, looking at the risks and doing risk assessments, internal audits, and looking at it as part of our corrective actions and the review of the management system. It's important, but I don't think it's a big issue for laboratories. It's a big issue for accreditation bodies, certification bodies. 4.2 is confidentiality. Again, this comes from the Casco requirements for 17025 for all the 1700 series. It's the same wording. By the way, this is not necessarily the wording of the standards. I've summarized it. You need to go back and read the standard after this before you do any sorts of assessment. You should be doing it against the wording of the standard. So we have to maintain confidentiality. Anything you find out should be kept confidential by personnel as well as by management, external bodies, anything. It should all be confidential unless the release of the confidential information is required by law. Simple as that. There are some additional complexities, but that's really what it comes down to. This doesn't mean just signing a non-disclosure agreement, but we have to make sure that we protect this confidential information in any format. So electronic storage and transmissions, we have to be careful about what information we're emailing, who we're emailing it to, that our systems are suitably secure so that people can't get in. If you need to put, laboratory needs to put information into the public domain or to release it, you need to tell the customer you're going to do this unless there's a legal requirement that you don't do this. So confidentiality, again, relatively simple. Anything you find out in the course of your business is confidential to your work and mustn't be released to other people. So now we get to section 5, and this is where we start to get into the real meat of the standard. The laboratory needs to be a legal entity, and it needs to be located at a permanent address. It needs to be something that can be found and something that can be sued ultimately, because your certificates are legal documents. If there's any issues with them, somebody may want to make a legal case. You have to identify the management that has overall responsibility for the laboratory. in previous standards, it used to say top management, and nobody really knew what top management was. So the first question an assessor would ask is, well, who's your top manager? Now this is slightly more logical. You need to tell the assessment body who has overall responsibility for the laboratory. And you have to define your organization, your management structure, your place in any parent organization, and the relationships between the management, the technical operations, and the support services. All of that needs to be defined. And then you need to specify who is responsible and who is authorized to manage, perform, or verify the work affecting the results of the laboratory activities, plus any interrelationships between these things. And one of the things that we used to have was we had a requirement for a quality manager. The new version of standard no longer requires that you have somebody called or doing the quality manager job, but you have to identify the personnel who have the authority to carry out the following duties. And these are the things that a quality manager probably would have done. These can be distributed, they can be with other people now. This is the way the system has worked. Personally, I think you still need a quality manager, but that's just my opinion. So, implementation, maintenance, and improvement of the management system. I'll stop just for a second. I tend to call it the quality system because I'm old, and that's what we called it 30 years ago. And then it became the quality management system. And now we're calling it the management system because the implication being that quality is implicit in the way we do our management. I suspect that in 20 years' time, we'll be calling it the quality system or the quality management system. Again, because we'll realize that quality is not implicit in the way we do management, but this is the current terminology. It means the same thing. The quality system, the quality management system, the management system, how you do your work, the processes and procedures that you follow to do your job. Identification of deviations from the management system or from the procedures for performing laboratory activities. So we have to look at when people are not following the system, when the system doesn't work, when the procedures for laboratories are not being followed. We need to look at somebody having this authority to initiate actions to prevent or minimize such deviations. This is corrective and preventive actions we often talk about. Reporting to laboratory management on the performance of the management system and any need for improvement. So somebody needs to make sure the laboratory management understand what's going on and is aware of any improvement. And someone also needs to ensure the effectiveness of laboratory activities. So these are quality manager type jobs. They can be distributed now, or they can all be given to a quality manager. That's entirely up to your organization. Your laboratory management need to demonstrate commitment to the management system to make sure that they communicate with the staff regarding how effective the management system is, the importance of meeting customers and other requirements. We'll talk about other requirements later. So the important thing is you have a management system and that your laboratory management are committed to following it. They don't say, oh, ignore those procedures and do it this way because we're busy or because they don't matter. The management system should be a document explaining the way you actually do your work. And any changes, when any changes are made, the laboratory management, the top management of the laboratory should ensure that the management system remains an integral unit, that it all works together so that you have a system that works and can be followed. The biggest risk of any laboratory, any quality system, is that people stop following the procedures and start doing their own thing, because often the procedures are out of date or not effective, or they don't reflect the way people work. And the risk, the big risk, is people start to do it their own way, and everybody starts doing it different ways. And that really, you have to minimize the opportunities for people to deviate from the procedures. And so the laboratory management have to be committed to making sure that this doesn't happen. So you have to have a defined scope of activities that the laboratory claim conform to ISO 17025. So if you're an accredited lab, you will have accredited scope of calibration, for instance. If you're not accredited or you do unaccredited measurements, then you need to have a scope which includes all the things that you claim conform to 17025. So that this is something we're all used to. If we've worked in accredited laboratories, we've always had a scope of calibration, and this is what this is asking for. You can't claim that you conform to 17025 for activities that you don't do, the things that you subcontract on a continuing basis. So if there's a measurement you send out to somebody else, it can't be in your scope of accreditation. And we talked about requirements. Everything you do, your activities, your process, your procedures must be structured to ensure that you meet the requirements of the customers, of the standard 17025, of your accreditation body, which may have additional requirements, and any regulatory authorities that may be working in your area. If you're in ionizing radiation, you'll have regulatory authorities that also have requirements. If you're working in aviation, you may have regulatory authorities, many other areas. So your activities have to meet all of those requirements. You have to gather those all in, and your procedures have to deal with all of those things. And all of this applies at your permanent laboratory. If you go out and do measurements on at the customer's site, if you have mobile facilities, you will find laboratories that have calibration labs in vans and drive around. And if you do anything at other sites, you may have some temporary or outstation sites where you do some calibrations. All of this still applies. All the requirements of 1705, the regulators, the accreditation bodies, and the customers have to be met wherever you're doing these calibrations. All of this, how you're doing it, your procedures need to be documented to make sure that you can provide the same service consistently and provide valid results. And this is the key point to quality systems in general and 17025. You start with documents which tell you how you do your job. You do your job and you produce records with your evidence that you did the job according to your procedures, according to your documents. How detailed do your procedures need to be to ensure the consistent application of your activities and the consistent validity of your results? Well, that depends on your staff and your level of training. If you have well-educated and well-trained staff with lots of experience, your procedures probably don't need to be as detailed as if you're using untrained or very loosely trained, very little trained staff. Then you may need a more detailed procedure to ensure that they achieve the same consistency. So this is one of these things that has to be assessed at the time. Do your procedures, your training and your staff mean that you can ensure consistent application of these
excuse me,
activities? John? Yeah.
This is Abdulillah from Government Secretariat. I have a question here about the requirements of regulatory authorities and customers and everything. If there is a conflict between their requirements, what's a procedure?
If there's a conflict, well, if there's a
Yeah.
conflict, I suspect that it probably goes in the order listed. Regulators are, you have to obey regulators.
Mhm.
That's generally a legal requirement. And I would think that then there's unlikely to be inconsistency between 17025 and the accreditation body, because the accreditation body has to be accredited itself. So I'm sure that those two won't be in conflict. They may add extra requirements, but they won't conflict. The customers sometimes will ask you for things that they shouldn't have, and they have to be discussed. There are some issues. There are some sections later on about dealing with customers who are asking for things that are perhaps not quite what they should be asking for. So I think regulators you have to obey. 17025 and the accreditation body as a unit you should be following. Otherwise, you can have not claim that you're accredited or that you're following the standard. And we can talk a little bit about customers. That will come later, about dealing with
yes.
customers.
In this case, who has to be set the priorities about these requirements?
I don't know. I've never come across this issue, and I've never come across anyone where we've had this issue. They don't often. I don't think the conflict is very likely, but I think it would be clear from the legislation that the regulators are key. You have to meet their requirements, otherwise you stop operating. Everything else, 17025, there's usually a way around meeting its requirements, I would suspect. So you'd have to deal with 17025 and the accreditation body and see if they will accept that as part of your accreditation. When it comes to the customer, then, as I say, there are some issues about how you deal with customers that are asking for things that are perhaps not appropriate, and we'll come to those later. So I think it's kind of a, you'd have to deal with this if it occurred at that time with your accreditation body, probably, or your customer.
Okay,
Because
thank you.
that sort of doesn't really answer the question, because I think that's one of these, right, let me take it aside here. Sometimes these things are black and white. If you go in as an assessor, there are things that have to be done, and there are things that you must not do. So some things are easy and some things are not. But sometimes it's a question of, is this sufficient? Is this document sufficient to ensure consistent application? Well, it's a judgment, and your different assessors will have different judgments in different circumstances. So often there are grey areas during the assessment. It's not all black and white. You have to do what you believe to be correct. The assessor will talk to the lead assessor. We may even go back to an accreditation body for advice on these areas where it's not clearly one thing or the other. So we often find these grey areas, and we have to decide what we think is appropriate. Okay, we get to the exciting part now. It's not very exciting. What's the most important things? If you're going to do calibration, you need personnel. You need some facilities with suitable environmental conditions. You need to have the right equipment. You need to have systems, procedures, software in place, and you need some support services. So you need to have all of these in place in a necessary to manage and perform your activities. Personnel are the most important part of any laboratory's activities. You can have all the equipment you like, you can have the best facilities, but your personnel are the most important part. We're talking about competence, and facilities can't be competent. Systems, unless they're perhaps artificial intelligence systems, can't be competent. Equipment can't be competent. It's only people that ever can provide you with the competence that is being assessed in this standard. So your personnel are the most important thing. Your personnel need to act impartially, as we said before. They need to be competent, and they have to follow the laboratory's management system. You have to document the competence requirements for each function, for your heads of labs, your technicians, your metrologists, the guys doing receiving and collection, any sales or support activities. If they have any influence on the results of laboratory activities, and most people in a laboratory have some effect or could have some effect on the results achieved. You have to document requirements for education, qualification, training, technical knowledge, skills, and experience. So this has to be written down, what competence is required for each role, for each job. And then the management has to communicate to the personnel their duties, their responsibilities, and their authorities. And most importantly, the laboratory as a whole should ensure that the personnel have the competence to perform the activities for which they are responsible and to evaluate the significance of deviations. So not only do you have to be able to do the job, you need to understand if something is different, if you're doing something different, if you're getting different results, and evaluate the significance of these things. You can't just be a robot. You have to think, you have to be able to understand what is happening in the activities you're doing. If something strange is occurring. People have to be competent. The assessment of competence is important there, and then they need to be authorized to perform the specific laboratory activities. Specific calibrations or tests. You can't be calibrating anything. You have to have specific calibrations, maybe by area, maybe by procedure. Again, they have to be authorized to analyze the results of probably specific areas, to provide statements of conformity, to report results, review them, and to authorize the results to sign the certificates as being correct. Also, people need to be authorized to develop, modify, verify, and validate methods. And people need to be authorized to provide opinions and interpretations. So this needs to be documented, the requirements need to be set up, people need to be evaluated, and then they need to be authorized to perform these activities before they do them. And as always, you have to have procedures and you have to retain records. So the procedures tell you how to do it, and the records are your evidence that you did it in accordance with the procedures. So you have to have the procedures for determining the competence requirements, selecting personnel, training personnel, supervising and authorizing personnel, and monitoring their competence. We cannot assume that because somebody did something once 5 years ago, they're still competent. So you need to have some sort of continual monitoring of competence of personnel, particularly if they're away for a long time, if they're in a different area, if it's a measurement that they don't normally do. Obviously, if you're doing something every day, your competence can change and you still need to be monitored. But the biggest risks tend to be when people go away and come back. Facilities and environmental conditions. So you have to document what facility and environmental conditions are necessary for whatever you're carrying out. This may be different for different calibrations. You have to control, record, and monitor the environmental conditions. So you specify them, then you need to control them, and you need to monitor them and keep records that you're meeting the specified requirements. You need to control access to laboratory areas and the use of areas affecting laboratory activities. People should not be doing maintenance, perhaps, or other things that are incompatible with the laboratory activities within the laboratory areas. We have to prevent contamination interference or adverse influences on laboratory activities. Contamination is a big issue in chemistry and biology. Interference can be in any area. Adverse influences, again, anything can be affected by that. Contamination is not usually a big issue for the physical metrology areas, perhaps things like pressure. We have to make sure that areas with incompatible activities are separated, and I've been doing this for 30 years, and I've still not really come across things that are incompatible, but you wouldn't want to be doing vibration measurements and mass measurements in the same laboratory or on the same bench. It's kind of self-evident, I think. So you have to make sure that activities which will affect each other are separated. And you need to ensure that these requirements are met, again, if you're outside the laboratory, if you're on site, you're making measurements in a customer's laboratory or out in the desert somewhere, you need to meet these requirements. You have to control and monitor and specify your environmental conditions and deal with any other different issues, including the access to those areas. This needs to be monitored and periodically reviewed. So the fact that you've set up your environmental conditions or your access control once when you moved into the laboratory is not enough. As well as monitoring what's going on, you need to periodically review the access control, review the environmental specifications. Do they need to be changed? Do they need to be made tighter? Do they need to be made broader? So these things have to be monitored and periodically reviewed. It's not a do it once and then forget about it. You need to have suitable equipment for the activities, for the things you're doing. Anything that could influence the results, it has to be available to you. Don't necessarily have to own it, but you have to have access to it. An example of the things you may need: the measuring instruments and standards. You may need some auxiliary apparatus. You may need pressure lines, compressed air. You may need vacuum pumps. You may need reference materials for the calibration or adjustment of certain instruments. You may need some reagents to do some activities. You may need consumables. You need wipes and gloves and cables and these sort of things. You may need software to do the measurements, and you may need, almost certainly will need, some form of reference data. So all of that needs to be available so that people can perform their jobs properly. If it's not available, then somebody needs to deal with that. You need to make sure that your measuring equipment is accurate enough to ensure you get valid results. So you shouldn't be making measurements with equipment which is not accurate enough for the job you're trying to do. You need to have some procedures to ensure that the equipment works properly and that it's not contaminated or deteriorated. So what does that mean? Well, we need to think about how you handle the equipment. Some equipment can be damaged in that way. How it's transported to and from the laboratory, and this includes when you're going to do measurements outside, or if you're sending it away for calibration, as often happens. How equipment is stored, are there special requirements? How equipment is used. So again, we often say that reference standards should only be used for specific calibrations. We shouldn't be using them for other measurements where they may be damaged in some way. And you should have some sort of maintenance plan for the equipment. So we're trying to make sure that the equipment works properly. And you need to verify the performance of the equipment before it's used or returned after maintenance. If you send it away for maintenance or calibration, if you get a new piece of equipment, it's been out of your control in any way, you need to check that the equipment is working correctly. What that means, what verification means, can depend on the equipment and on how you're using it and the procedures in your laboratory, and to some extent what other standards you have to verify it. But your assessors will be looking for you to do the best job you can of verifying that equipment is meeting its specification and performing correctly. Your measuring equipment needs to be calibrated, but it only needs to be calibrated when it's required for one of two things. Either we're establishing the metrological traceability of the reported results. So the standard you're using has to be calibrated and it has to be traceable. Or the measurement accuracy or uncertainty of the instrument that needs to be calibrated affects the validity of the reported results. So an example is if you're doing a mass measurement, you're measuring masses on a balance, the balance would need to be calibrated. If you're calibrating balances, the masses would need to be calibrated. But you also need to understand the temperature, the humidity, and the atmospheric pressure. And that's the other results that affect the validity of the measurement. In resistance, you need to have a traceable resistor, but you also need to know the temperature. You may need to know the current that you're measuring at or the voltage you're measuring at. So there are always some peripheral measurements that affect the accuracy or the uncertainty. So for any equipment that has to be calibrated, you need to have a calibration program. You should have a procedure for intermediate checks for that equipment. And intermediate checks tend to be done once between calibrations. It's not the only way in which we can establish things, but it's the most normal that we do a calibration, say every year, and we do an intermediate check every 6 months. But those separations depend on your calibration program, and your calibration program should be made to make sure that you're going to get sufficient accuracy for your measurements. Everything that you're using that needs to be calibrated or verified shall have some form of way of identifying calibration status. Usually we have a calibration label, which tells you when it was calibrated and when the calibration is due. So everything should have that on it, so that when you pick it up in the laboratory, you go, oh, this one's not calibrated, I can't use that. I need to find another one. If it's not calibrated, it should be segregated, and we will talk about that in a moment. You need to prevent any unplanned or accidental adjustments to equipment. Generally, this involves one or two things. Either there'll be some password to prevent you accidentally adjusting an instrument through software, or there may be some seals, calibration void if broken. You'll see it on many pieces of equipment to prevent some mechanical actions that will change the value of the equipment. We're talking about unplanned or accidental adjustments here. Hopefully no one's going to maliciously adjust your equipment, but there is always a possibility someone will make a mistake, and that's what we're trying to prevent. So if you have equipment that you think may not be working properly, it might not be performing to specification, it seems to you to be defective, or it's incorrectly handled, maybe you dropped it, or you've been overloaded, or you've put the wrong current into the wrong measurement points. It's very important that you stop use of this equipment. And it's very important that you take that out of service until it has been verified. And we need to look at the non-conforming work procedure here. It's really important. There's nothing worse than someone dropping something, putting it back on the shelf, and you use it for some months, and then you realize that something's happened to it and the value's been wrong. And then you have to go back to your customers and withdraw your certificates, and you have to fix these issues. It's much better to know on the day. And as a head of lab, I try not to get cross with people who have dropped or broken my equipment. I do sometimes, but it's much better that they know now than that I know later. So for anybody who works with me, if they do damage some equipment and I know it will be accidental and I get cross with you, I apologize in advance, because it's the right thing to do. Tell your head of lab, tell someone immediately and take that out of service, because there's nothing worse than using defective equipment to do calibrations.
Sorry, can I ask a question?
Yes, yes.
Yes. What do you think about if the calibration done by the third-party entity?
So when you send something out for third-party calibration, when it comes back, you should be checking that it's working properly. My advice would be that you should do some checks before it goes out and when it comes back. And that's what we do, certainly for our reference standards, to establish if any changes have happened during transport or calibration. So definitely the requirement is that you check it working properly when it comes back. Does that answer your question?
Yes, okay, thank you.
Okay. When it comes back from calibration, there'll be reference values or correction factors, and these may be used in your software. You may have some programs that use these values to calculate the factors for calibrations. This is very common, and it's something that people very often miss updating. It's one of the things I've found many times when I go around doing audits. Someone's had their instrument back from calibration, but they haven't changed the reference values or the correction factors in the software. You need to make sure you've got a robust system that ensures that when that equipment comes back, one, you check it, as we just discussed, and two, that you update any reference values that are using that so that you're not using previous data. It's very simple, but it's one of these things that is forgotten surprisingly often. Sometimes you may have equipment that's not yours. It's not in your permanent control. You may share it with another laboratory, another part of your organization. You may rent it. You may borrow it. All of this is fine, but you need to make sure that all of those requirements are met when you're using that equipment. So you need to check it. You need to make sure that it's not been damaged. You need to make sure it's been calibrated. It's all fine. You can do that. Sometimes people do have to borrow or use equipment that is not theirs. You just need to make sure that it meets your requirements and it's properly operating. Equipment records. Equipment records are a very important part of what we do in the laboratory. Every piece of equipment is a unique item. It needs to be identified with its serial number, its software and firmware versions. You need to know where it is. You need to provide the evidence or show where the evidence is that it was verified that it met the standard specified requirements when it was new, when it was repaired, after it was calibrated. You need to keep a record of when it was calibrated, what the results were, when it was adjusted. You need to have acceptance criteria, and you need to have the calibration intervals or due dates. So you need to understand this equipment, how many times it's been calibrated, when it was calibrated, what the intervals are, what the results are, how often it needs adjustment. You need to maintain a maintenance plan. You need to keep record of the maintenance that was done, and you need to keep records of any damage, malfunction, modification, or repair of the equipment. This is so we can go back, and if we need to, we can look at results done with that equipment, measurements made with that equipment, and if we need to withdraw them. And we also need to think about whether it needs replacing or upgrading in any way. Reference materials, again, similar. Results, acceptance criteria, relevant for dates and the period of validity. Slightly different, but the same principle. We need to know what's happened with those reference materials, how long they last, and if they have acceptance criteria. So the equipment records are very important. They give you the history of your items. The next section is metrological traceability, and this is one of the few definitions that are in this version of the course. Metrological traceability is the property of a measurement result where it can be related to a reference through a documented, unbroken change of calibrations, each contributing to the measurement uncertainty. So a chain between your measurement that you've made and somewhere a realization generally of the SI units. That's what we're looking for with metrological traceability. You have to document the metrological traceability for all the equipment that contribute to the overall measurement uncertainty of your test or calibration results. So you have to establish this linked, unbroken calibration chain. And this traceability to the SI is a core requirement to ensure that laboratories are demonstrating the competence and the ability to provide consistent results, because you have to have the traceability. And provide the traceability and the accreditation ensures that your measurement results can be accepted internationally. So this is one of the things from accreditation, that your results are valid and acceptable anywhere. Through the ILEC MRA, your accreditation body will have been accepted, and anybody who's accredited by them can provide calibrations anywhere in the world. And through the CIPM MRA, the NMIs with published case CMCs on the KCDB can provide calibrations anywhere in the world, and they will be accepted. But this is all based on traceability back to the SI, because that's the core technical requirement for that. So how do you ensure your measurement results are traceable to the SI? Well, one is that your calibration is provided by a competent laboratory. And how do we identify competent laboratories? Well, they meet the requirements of ISO 17025. That's how we know if you're competent. You may be using certified reference materials, and they may be traceable to the SI. And if those are traceable, SI traceable certified reference materials, if they're produced by reference material producers that meet the requirements of ISO 17034, they're also competent. So you've got traceability. You may also realize the SI units within your laboratory. You may realize the meter or the second, or you may realize the Kelvin or anything. Any realization of the SI units has to be ensured by a comparison with other national or international standards. You need a comparison result before you can claim that your SI units provide you traceability. So this is a very important issue. And for some realizations, there is a time limit on how often you need to run the comparisons. I think this is true of dimension. I think you have about 10 years between comparisons. For others, there is no strict time limit. But if you realize it, you have to have a comparison so that you can claim metrological traceability. There are some units that we calibrate to that are not technically traceable to the SI. So not just because you don't want to, but because they're not SI traceable units. There are quite a few examples in chemistry, none of which spring to mind for me. But the one I always remember is hardness. So the hardness scales, the Vickers and the Rockwell hardness scales, are not traceable to the SI units. Various aspects of the measurements are the dimensions, the masses, the forces used are SI traceable, but the units themselves are not SI units. So if you have one of those, how do you demonstrate traceability? Well, either you have certified values of certified reference materials provided by a competent producer. And again, ISO 17034 is the competent producers for certified reference materials. Or you may use a standard reference measurement procedure, a specified method or a consensus standard that is clearly described, that is internationally accepted as providing the right results. And if you use that, you also need a suitable comparison. So again, comparison is a very key part of this. We talked about labs demonstrating their conformity with ISO 17025. There are different ways of doing this. Third-party recognition, so being accredited is one of those ways, and also peer review through the MRA system. An external assessment by customers. This is quite common, or it used to be quite common, particularly in the nuclear industry where I worked for a while, that your customers, even if you were accredited, would want to come and do an external assessment to ensure they believed they accepted your conformity. Or you can have self-assessment. And I usually make the example of this, that if you're PTB in Germany and you say we meet ISO 17025, I very much doubt anybody's going to argue with you. But if you're EMI in the UAE and you say we're self-assessed to ISO 17025, I suspect people will go, okay, well, that's what you say, but why should we believe you? So self-assessment only works when you have a reputation and history that people are going to believe it anyway. So generally we look at third-party recognition, an accreditation body or peer review through an RMO such as GulfMet to demonstrate conformity. So this is third-party recognition. I think I've said that already. NMIs, they're peer-reviewed under CIPM MRA, third-party recognition, and their services that are covered are published in KCDB. And laboratories that have been accredited by an accreditation body subject to the ILAC arrangement. Those scopes are publicly available from the accreditation body. So third-party recognition, one part of this is that the scope of your accreditation, the scope of your CMCs is publicly available. Anybody can check what your capabilities are. Externally provided products and services. So you're going to rely on some externally provided services. There are things that you're going to put into your own activities. There are things you're going to provide to the customer, and there are things that are used to support the operation of the laboratory. These might be your measurement standards, buying new measurement standards, buying auxiliary equipment, consumable materials, reference materials. They may also be services, your calibrations. You may have sampling or testing services if you're doing that, facility and equipment maintenance services, proficiency testing services, and your assessment and auditing services. So all of these will have an effect on the output, the product that you provide to your customer. So you need to make sure that your system, your procedure is in place so that your external providers, your service or product providers understand your requirements, they understand your acceptance criteria, and where necessary, competence of personnel providing the service. This comes up when it comes to accreditation. If you're a DI or an NMI, you would like to publish your CMCs on the KCDB, there are specific competence requirements for the assessors. You need to make sure this is clearly understood by your accreditation bodies. You need to have procedures, and how you're doing this, you need to keep records to provide evidence that define the criteria and describe how you do the selection, evaluation, and monitoring, how you make sure the equipment is suitable, and any actions arising from evaluation, monitoring, and re-evaluation of external providers. Often a lot of this is covered by your procurement department, and if you're governmental, it may be out of your hands. But you need to have an interface. You need to have some procedures internally which link to the procedures provided by your higher organization to ensure that these things are met. And you may need this evidence. Supplier evaluation evidence, for instance, we need to get that from our procurement department and ultimately from Abu Dhabi government when we're doing these evaluations. It's not something that's available to us within EMI. So next section is process requirements, and I will start this, but at about 11:30 UAE time, we'll take a break. So sometime in the next 20 minutes, we'll take a break, but somewhere in section 7. So these are the processes that you have to have in place, the processes and procedures that are required. One of the really key ones is something we tend to call contract review. You have to have a procedure for the review of requests, tenders, and contracts. And what we're trying to do here is that we understand the customer's requirements. We make sure that we clarify their requests, that their requirements are adequately defined, documented, and understood. So we know what the customer wants. We make sure that we have the capability to meet the requirements, that our measurement capability is sufficient, and we have the resources. So we have people, the equipment, the facilities available to do that work. We make sure that we've selected appropriate procedures to meet the requirements. And this is one of those areas when we were talking about before. Your customer may ask you to do a measurement following a method that's inappropriate or out of date. One of the things that often happens is there's a manufacturing standard for some item, and the customer will ask you to do a calibration to the manufacturing standard. The manufacturing standard is not an appropriate standard to follow. Or they may ask you to use a previous version of an ISO standard, which has been replaced. So you need to tell them that the method is inappropriate or out of date. At the moment, we're not saying we won't do it, but we're telling them we have to inform them if it's out of date. Then you have to resolve any differences before laboratory activities commence. If you accept any deviations from the customer, it shall not impact the integrity of the laboratory or the validity of the results. So you should only do things that are proper to be done. So maybe your customer needs you to do a calibration against an old version of a standard. Maybe they have some old equipment that requires some specific parts that are in that standard and not in a later version. That would be fine. You need to agree that. You need to make sure that you can provide the right results and that you're not impacting your integrity. You're doing the right thing. If there's going to be any deviation from the contract, the customer needs to be informed. And if there's any amendments afterwards, then you need to go back and look at that and communicate it and review the contract again. So it's really, really important that you understand what the customer wants before you start and make sure you can deliver it. This is one of those things that occasionally happens in all laboratories. You think the customer wants one thing. The customer thinks you're going to deliver something else. And at the end, you've done some work which the customer is not willing to accept. It happens. The idea of this process is that we stop it happening completely. Often the communications are not good enough and occasionally problems occur. It happens to all of us. So these things we should try and stop happening before, because we're talking about customer satisfaction. If your customer believes you're going to do something and you do something else, they're not going to be satisfied. So you need to try and clarify this, but occasionally it doesn't happen, and that will be managed in your non-conformity process. Hopefully you can amend your procedure and stop it happening again. The laboratory has to let the customer come and witness laboratory activities. Laboratories, occasionally customers want to come and witness what you're doing, witnessing your calibration. It's one of the most awkward things for a laboratory. You're trying to do technical work, you're trying to get this job done, and you've got someone watching you over your shoulder. It's a very distracting and difficult process. Sometimes it's for good reasons. Very high consequence industries, they want somebody of their own to witness you doing the measurements to make sure they were really done, and so that they can provide assurance to their management. Often it's done because somebody wants to steal your procedure. Usually they want to come and watch how you do the measurements so that they can do it themselves. But you have to provide them the access. It's difficult for a laboratory and something we try and minimize, I have to say, but we have to do it. There may be also items that the customer needs for verification. You may need to pay, pack and dispatch items. So you have to work with the customer to try and deal with these things. So this is a routine job, an internal job. Then the review of the requests can be simplified. You don't need to go through an enormous amount of detail for a routine measurement, because you already know what's required. You already know what the customer expects, and you already know if you have the capability, so that you can simplify this process. As ever, you need to have a procedure and you need to keep the records so that when your assessors come, they can go through and see if you did do what you said you were going to do as part of the process. One of the things that comes here, sometimes you may use external providers for part of the service, or for a calibration, you may need to send something out to somebody else. Often commercial laboratories have contracts with big organizations where they provide all of the services, but they subcontract some stuff. Not so much, I think, for government labs, but it may still happen. The important thing is you make sure, following 6.6, that these externally provided services are suitable. You have to tell the customer which laboratory activities are going to be performed by the external provider. So you have to be open. We're not calibrating this. We're going to send it out for somebody else. And you need the laboratory, and you need the customer's approval for sending these things to an external provider. So that's a very important point if you're ever sending work out. Okay. The customer may require a statement of conformity, a pass-fail, or a class 1, class 2, or an in and out of tolerance statement. If they want this, there are things that must be clearly defined. You need to know what standard you're trying to pass or fail it against, and you need to understand the decision rule, unless it's find in the standard or specification. So the decision rule is how do we
هذا
include the
الشيء.
measurement in certainty in the conformity statement. So we've got a measurement and we've got an uncertainty, and we need to know how we're going to address this. It comes up again in clause 7.8, reporting of results, and I believe, because I'm not going to talk about it in any depth, I believe that Dr. Christos is going to give you a course on conformity statements at some point in the future. So I think this is probably a good point for me to pause. So I'm going to stop for 15 minutes now. Go and get a cup of tea or have a break or a walk, and we'll come back for the rest of 7.2 and the rest of the presentation. So I'm going to take a 15-minute break. So that will be, it will be 35 here in the UAE when I come back, or 35 minutes past whatever hour it is, wherever you are now.
John, thank you very much for this presentation. Please enjoy your break. And I would like to mention that please put your name and your institutes, your country also in the chat box, so we can do a certificate of attendance. This is very important. I have also put in the chat the previous course, which is been organized, the link for the previous course. It was recorded, and you can enjoy also listening to that course. We have, I would like also to mention that we have received also your certificate from PIPM for the previous course, and it's ready for signatures. We will dispatch to you very soon. These things should be, and again, I would like to emphasize that these training courses, it's a free requisitions for your qualification. So please pay attention to all. As John is highlighting, that we will have courses in validations of the calibration results, validation of calibration methods. This is gonna be organized very soon, probably in the of August and beginning of September. So we are preparing these courses. Also be included practicals workshop to validate some. So it's been also organized to support you as a potential peer reviewers. So enjoy your break, and please pay attention to the clock counters for the break. My colleagues, they is putting the clock counters for the break, 15 minutes. Thank you very much.
Thank you. We'll see you in 15 minutes.
John, you are with us?
Hello.
Yes,
So-
John.
Sorry,
Yes,
that
you
was
are on time.
that was me and not my computer this time.
Ah, so
I'm a bit
you
bit
calibrate
slow
your
in
watch.
restarting. So let me try and open my. Can you see that?
Yes, yes, we can see.
Oh, excellent. Right then, if you can see the slides, then I will start again. As I mentioned before, I can't see any of the team stuff. So if you're putting your hand up or anything, I will not be aware of it. So please speak if you have any questions.
John, can I just have this announcement from PIPM regarding the previous course? I got just an email from Jinkies from PIPM. It says that they have transferred the recorded courses, and he's giving me another link so they can find, it was in the Google Drive in temporary base. Right now he is moving, the whole materials and recorded courses to permanent place, and I will give you in chatting right now what it will be. That I just received, the email. Maybe you are just trying. Yeah, this is which I have got right now. That this is another link which you will find the previous course in it. Please consider that. Thank you very much. Back to you, John.
Okay.
By the way, this course is also recorded, and we will send you the link for that.
Excellent. So you can do this again if it wasn't thrilling enough the first time. So second half of the course, second half of the standard. I've got about as many slides now as I had to start us off, so we'll go through this. We have to look at the methods. And it says methods, it
John,
really
sorry really to interrupt you.
Yes.
But it's a chance before we start the second sessions, just to have a group pictures. Could we do that?
Okay. That involves me
So
doing fancy stuff like turning my share off, doesn't it? Oh,
I would like to invite all the participants to open their camera and ask my colleague if they can take a screenshot of that. Okay, I'm seeing very beautiful faces. Anas, good morning, Anas. How are you?
Good morning.
Good.
How are you?
Looking
Nice to see
forward
you
to see
again.
you from Syria. Yes, Dr. Anas.
Thank you very much.
Okay, very nice. Please try to open your camera. Yeah, Abu Saud. Are you ready, Abu Saud? Smile, smile. Ready, Abu Saud? Just be patient with us. My colleagues is trying his best to catch all the faces in one shot. Yes, my. Yeah, let's start counting. 1, 2, 3. Smile. Yeah, done it. This is the first shot. The second, try again. 1. Okay. Yeah, again. 1. Yes, start again. 1, 2, 3. Smile. Okay, is that right? Yeah. So all, you catch all the faces. Excellent. Thank you. Back to you, John. Keep your
Okay.
camera on. Don't worry. Okay.
Don't worry, because I can't see you once I start talking. So hopefully you can see my slide. And you can hear me. I've got, hang on. This process does not get any easier, no matter how many times I do it. Right, so methods, the procedures we use. I've never quite understood ISO 17025 since the very beginning has always referred to methods. Well, as far as I know, the calibration and testing community have always referred to procedures. I don't know why we have this, but it says this. So the selection, verification, and validation of methods is crucial to ensure the validity of results. Absolutely. You have to be doing the right measurements and you need to prove that you can do them and that they're achieving the right results. So we have to select suitable methods and agree these with the customer. And there's a list of what we can call as recommended methods, such as those published in international, regional, and national standards, reputable technical organizations, in relevant scientific texts or journals, or as specified by the manufacturer of the equipment. We should always try and use the latest version of a method. It's not appropriate or possible to do so. Sometimes it might not be appropriate. It may be that the equipment won't perform using the latest method. Sometimes it may not be possible. Perhaps the method's just been updated and you don't have the appropriate equipment to do the latest version yet. So you may not be able to do it. We also have to use appropriate methods for the evaluation of the measurement uncertainty and statistical techniques for the analysis of data. So we'll come back to that when we come to measurement uncertainty. And I'm suffering from my problem again. There we go. You need to keep your methods, your procedures, your supporting documentation up to date, and you need to make sure they're readily available to your personnel. So if you're in the laboratory and you're doing the work, you need to have access to your procedures. Before you start doing a method, you need to verify that you can perform it properly. And you need to keep records of that verification. And if you revise the method, or if the method is revised, if it's an international standard, then you have to repeat the verification to the extent necessary. This is much more explicit than it used to be, so we need to make sure that we really are doing this. Deviations from methods should be documented, technically justified, not just because you think it's easier or quicker, but there has to be a technical reason why you're going to deviate. They need to be authorized by somebody suitable within your organization, and they have to be accepted by the customer. So we're trying to follow methods that are consistent, preferably that are internationally recognized, because it makes it easier to deliver the right results. Sometimes you need to develop methods. You need to do something different. And if you need to do that, you have to have a plan to do this development. It shouldn't just be something you do. One day you start developing a new method, there should be a plan, and it should be assigned to personnel who are qualified and have the required resources to perform the task. So it should be a planned activity, not just an ad hoc thing. If you develop a method or you modify the method, then, or you're using non-standard methods, or where you've changed the scope of the standard methods, you need to do validation. Now, validation is a much higher threshold than verification. Verification is proving that you can do it. Validation is proving that you get the right results. The extent of the validation is dependent upon what parameters are required to provide performance results that confirm suitability of the method for the intended use. Usually I'm giving this course to calibration laboratories, and usually at this point I tell them, don't develop any methods and don't do any validation. There's almost no reason why a calibration laboratory will be developing new methods, because most things are already developed and documented and you can follow standard methods. But my audience today is slightly different. We have NMIs here, so you will probably at some point develop a new method, a new procedure, a new way of doing a measurement, or you'll modify one beyond the point where you feel it's necessary to validate it. And therefore you're going to have to do validation. I haven't done it very often. In 30 years, it's something I've done once or twice, and validation is tough. And I would advise you to avoid it if at all possible. But sometimes you're going to have to do a new measurement. And when you do that measurement, you're going to have to validate it. But proving that you're doing the right thing and getting the right results is quite a high threshold to achieve. If you're doing validation, you need to use appropriate methods and procedures. There is a lot of information in the standard, and there's lots of information elsewhere to help you with this. You need to determine the influence of any changes to a validated method, and you need to retain records of the validation, the procedure, the requirements you were validating against, performance characteristics, the results obtained, and importantly, a method validity statement. So you need a statement that this procedure is fit for calibrations against these requirements. It's fit for its intended use. You need to make that statement. It's a high threshold, so it's something that if you have to do it, you need to think about how you're going to achieve that. There's a lot of extra advice in the standard which I haven't talked to you about here. Okay, selection. Oh, have I gone the wrong way? Yes, I've gone the wrong way, sorry. Sampling. So this version of the standard now has much more extensive requirements for sampling. My assumption is the audience we're talking here don't really deal with sampling, so I'm just going to give you the basics that you have to have a plan for sampling, you have to have methodology, and you have to record any information so you could go back and find the traceability of the sample and ensure that subsequent testing results are valid. So not something we do a lot of. If you need more advice on it, there's a lot more in the standards on sampling. Handling of test and calibration items. So anything that comes in for calibration, for testing, you need to have a procedure for the transportation. And if you arrange that, receipt, handling, protection, storage, retention, and disposal if necessary, or return of your test and calibration items. Why? We want to protect the integrity of the test or calibration item to make sure it's the right item in the right condition to do the calibrations, and also to protect the interests of the laboratory and the customer, that we're not damaging or losing any equipment which belongs to one of our customers. So we have to avoid deterioration, contamination, loss or damage to the item during handling and transportation, storage and preparation for calibration. And there may be handling instructions provided, so if they are provided, they should be followed. Generally, in the sort of calibration of instruments that I've been involved with, each item has a unique identification. It has a serial number, it has a model number, so that we can track that system. We can track that serial number, that item through the serial number. But for instance, in testing in pharmaceuticals, you may be given a sample of medicine, of tablets or capsules that have to be identified and they have to be managed. So that can be an area where there is a system to identify the items when they arrive. Occasionally you get items which don't have serial numbers, and I have even on occasion have two items of the same model from the same manufacturer with the same serial number. And so you have to be able to deal with that situation as well. Sometimes items need to be stored or they need to be conditioned under specified environmental conditions. And we're back to the same process as always. If there's a specified condition, then you need to maintain it, you need to monitor it, and you need to keep records to prove that that condition was met during the storage. So sometimes you get an item that's not what you were expecting, perhaps, or it's damaged in some way. And this is what we're looking at here. Any deviations from specified conditions on receipt of the test of calibration item. So someone may send you something and you're not sure whether it's suitable for calibration. It may have been damaged. It may not be what you were expecting. You need to talk to the customer for further instructions before proceeding, and you need to record the results of this consultation. Often you won't do these calibrations, but there may be a good reason why a damaged piece of equipment needs to come in. Perhaps a customer needs to know what the results were, what difference this made to its readings. It's possible, it's unlikely. So when you have to do this measurement on an item that is in some way not ideal, we have to include a disclaimer in the certificate, in the report, indicating what was wrong with the instrument and which results may be affected by the deviation. It's something that happens occasionally, but it's not something that we come across very often, I think. Okay, technical records. Technical records is another important thing. As we said before, records are documents, they're the evidence, they're the information created as part of performing an activity, it says here. You do something, you produce records. You do a calibration, you have technical records of the calibration. It's very important that the minimum set of information recorded on the technical records, which we're going to go through now, is kept. We need to make sure that we keep the results, we keep the report or certificate, and we keep sufficient information to facilitate identification factors affecting the measurement result and its associated measurement uncertainty. What does that mean? We need to know what procedure we were following. We may need to know temperature and humidity, possibly air pressure. We need to know which standards and which instruments we used for the measurement. We may need to know where we measured it. We may need to know who measured it. And we need sufficient information to enable the repetition of the activity under conditions as close as possible to the original. So these two things are very similar. We need to know those factors that may have contributed to the result or the uncertainty, and also if we need to replicate it. So it's very important that we keep this data, that we can identify it to a specific job, and that we have kept all of that information together. Those technical records have to include the date, the identity of the person responsible for each activity. So person did the measurements, person who checked the data, and the person who produced the results. When there are original observations, they have to be recorded at the time they are made. We don't want them rewritten afterwards. It's not like when we were at school and university where we would write our notes for our experiments and set them up neatly to hand in later. We want your scruffy results and we want them captured, and we need to keep them and they'll be identifiable with specific tasks. So again, we need to know the serial number, maybe the job number, something so that we can track them, whatever you decide. Any amendments have to be able to be tracked to previous versions or to the original observations. Often these now are not paper. These may be things written on entered into Excel sheets or into software. So we need to keep the original data file or the original paper records. Sometimes my young colleagues have started to take pictures of readings, which is a great step forward. We all have these phones with us now. Rather than trying to write results quickly, you can take a lot of photos very quickly. We need to keep that data as the original record. So we need to make sure we've got that. We need to know if we made any changes. We need to know who did it, what was changed, and when. So we need to be able to track the original results through to the final results and know what changed when, because sometimes a mistake is made and we need to go back and rectify it. So this is what we're looking for with this process. Measurement uncertainty. And again, I'm not going to talk a great deal about measurement uncertainty because I'm sure that Omar is arranging a whole talk on the subject. But what do we know? A laboratory performing calibrations, including for your own equipment, shall evaluate the measurement uncertainty for all calibrations. This is not something that's always done by the commercial laboratories. When they're claiming they're out of accreditation, they quite often send out certificates without measurement uncertainties. I'm sure you don't do that. If you're doing testing, you should evaluate the measurements uncertainty when you can, but I don't think we have any testing labs here, and I'm definitely not an expert on the testing area. You have to identify the contributions to the measurement uncertainty. You have to identify where they come from. And when you evaluate your measurement uncertainty, you have to include all significant contributions, including those arising from sampling, and shall be taken into account using an appropriate method of analysis. Well, we'll leave that to whoever's teaching you about uncertainty, but we're looking at the guide, the GUM here, the guide to the uncertainty of measurement. That tells you what appropriate methods of analysis are. Ensuring the validity of results. We want to have a procedure to monitor the validity of results, both internally and externally. So some things you can do internally to monitor your results and some things you can do externally. We'll talk a little bit about that in a minute. The important thing is the monitoring should be planned and it should be reviewed. There's no point doing it if no one's looking at the results. You need to monitor, record the data so that you can detect trends. And you can use statistical techniques to review the results. Often statistical techniques are useful. Sometimes just a plot can provide you with the information you need. So you need to look at what's appropriate and what your understanding level is in different laboratories. What are we trying to do? We're trying to analyze the data and we're using it to control and improve the laboratory's activities. So what we're trying to do is to check that our results are good as far as we can, internally and externally. If the results you found are outside the predefined criteria, then you have to take some actions to prevent incorrect results from being reported. This is the point of this. So the purpose of the internal controls is to provide assurance that the current test or calibration achieves the validated method performance. We've done a validation, we've done verification, we know we can do this measurement. What we want to do is to check that today we're getting the right results. And that's great, but the standard also requires us to monitor our performance externally by comparing results and performance of other laboratories. So this is the external proof that we are getting the same results as somebody else, to identify if there's any bias in their measurements or deficiency in the uncertainty budget. Are you getting the right answers, and are your uncertainties realistic? So generally, for each method in the scope, participation is required in a proficiency testing or an interlaboratory comparison. Generally, for NMIs, we're looking at interlaboratory comparison programs, but proficiency testing programs are something that we tend to run more for the accredited laboratories. There's not a great deal of difference between them for calibration, but it's really important because this is the comparison that proves that your whole system works and that you get comparable results, which is why we put so much time and effort into our ILCs with engulfment. Okay, now we get into the wonderful lists. Reporting of results. The important thing to remember is your calibration certificate, your test report, is a legal document. It's the output of a contracted service for a client, and it's a document which could be used to support a number of specific regulatory requirements. So this is a really important document. This is not just some piece of paper. And one of the things I would say to you now is, if somebody gives you a certificate or you do some measurements and you're not happy with the results, you should not sign the certificate. You should only sign a certificate if you're happy with. This is your signature. It's a valuable thing, and it should only be on that document once you're happy that the results are realistic and correct. General about results. The results should be reviewed and authorized prior to release. So we want a second set of eyes on the results. Somebody does the calibration, somebody reviews them, and somebody authorizes them. That might be a third person, or it could be the second person, but we want at least an independent review. The authorization has to be by someone who is authorized to do that. Results shall be provided accurately, clearly, unambiguously, and objectively, usually in a report. That's a great set of requirements in a very short length of time, but we do pretty well providing those things. The report shall include all the information you agreed with the customer, all the information that's necessary for the interpretation of the results. There may be something that you need to say about how you did the measurements or some specific details of that, and any information required by the method used. So if you're following a standard, it may require you to report specific things. And you need to keep these reports or certificates as technical records. Sometimes, when agreed with the customer, the results can be reported in a simplified way. But you need to make sure that you have all the information you haven't reported to the customer. So you need that information whether you've provided it to them or not. This tends to happen more with internal calibrations within large organizations, where they give a very simplified report to the using part of the organization and keep the data within the calibration organization. And they often manage everything about the calibrated equipment, so the shops outside don't need to have that information. This is important. The laboratory is responsible for all the information provided in the report, except when information is provided by the customer. Anything that goes on your report is your responsibility. If the customer gives you data, you need to clearly identify it, and you need to put a disclaimer on the report about how that can affect the validity of results. And if there's a sampling stage and you weren't involved, you need to state that the results apply to the sample as received because you know nothing about the sample. So there are a list of common requirements for reports, and it's very, very small because I'm not going to talk about it. The list is there. It's very simple. When you're looking at your reports, when you're producing your reports, go and check the list. Make sure that you have everything in there that's required. I'm not going to read it all. Test report as well, there are specific requirements, and I'm not going to read you those either. However, specific requirements for calibration certificates. The measurement uncertainty of the measure end results shall be presented in the same unit as that measure end or in a term relative to the measure end, so percent perhaps. This is something that's generally followed, but there are some specific examples where people seem to report the measure end in one thing and the uncertainty in another. It seems to happen with thermocouples, and it seems to be accepted, but generally they should be either the same unit or in relative terms. You need to record any relevant environmental or other conditions under which the measurements were made, anything that would have an influence on the measurement results. And you need to include a statement identifying the measurements are metrologically traceable. If you've done any adjustment or repair, and you did measurements before and after, then you need to record both of those. If there's a statement of conformity with requirements or specifications, then you can include that. There's more information on that in 786 later. Where appropriate, opinions and interpretations, which is in 787. I will once again give my opinion here that I don't believe that opinions or interpretations should be on a certificate. I believe a certificate should be a statement of fact, and opinions and interpretations should be on some other document, but it is allowed. So if that's the way you want to deal with that, that's fine. But my opinion is you shouldn't be putting them on a certificate. If there's any sampling, you have to make sure you report the sampling in accordance with the reporting of sampling requirements. And my favorite one, the one that upsets almost all of our calibration laboratories in the UAE, a calibration certificate or calibration label shall not contain any recommendation on the calibration interval, except where this has been agreed with the customer. So you cannot put a due date on unless your customer has told you what the due date is. Again, I suspect for this audience that's not a problem, but this always causes me problems for the accredited labs in the UAE. They accept it, but they really don't like it. Reporting of sampling, it's there. If you are doing any sampling, you need to follow that. Okay, reporting statements of conformity. I'm not going to talk to you in great detail about this because you're going to have a specific course. But sometimes you have to provide a statement of conformity to a specification or standard. So a pass-fail against specification, a classification of a class 1 or a class 2 instrument. When you're doing that, you now document the decision rule employed, taking into account the level of risk, such as false accept, false reject, and statistical assumptions associated with the decision rule applied, and apply the decision rule. So the first thing I'm going to tell you about this is this is wrong. I don't believe that you're taking into account the level of risk. Risk, as you will, I think, learn tomorrow, is about probability and impact. If you go into the standards about this, we're not talking about impact. We don't know what the customer's using it for, or what how the risk of false acceptance is really implemented. But we understand the probability. That's a statistical thing to do with our measurements. So I believe this should say taking into account the probability of false acceptance and false rejection associated with the decision rule applied. Sometimes your customer will tell you the decision rule, or it will be in your regulations or your normative documents. And then you don't need to think about the level of risk or the probability of false acceptance and false rejection. Also, if you're reporting a statement of conformity, you need to say to which result statement of conformity applies, which specification standards or parts thereof are met or not met, and the decision rule applied, unless it is inherent in the requested specification or standard. So I'm sure we've all seen certificates that say the instrument meets all published specifications. Well, that's not good enough. You can't say that. We need specific information on what parts of what specifications it meets. Dr. Christos will, I think, be giving you some more information on decision rules. It's an interesting subject. Opinions and interpretations. The important thing here is that only personnel authorized for the expression of opinions and interpretations shall make them. And you should document the basis upon which the opinion and interpretations have been made. We're not talking about pass fail. We're talking about opinions. Do you think we can use this for that? Should we be replacing this one? Is this all right for such and such? Or maybe something more formal than that. But this is the ones that generally happen. If you're putting these opinions in reports, they should be based on the results in that report and clearly identified as such. The last one is the one where we sometimes make a mistake. When opinions and interpretations are directly communicated by direct dialogue with the customer, a record of the dialogue shall be retained. And this is what happens, is the customer says, well, is this instrument all right? Is it still behaving all right? Can I use it for this? And we tend to be helpful. And we tend to say, yes, this will be fine. So the important things is, unless you're authorized to make that statement, don't make it. And if you do make it, I would recommend you record it. And the best way is probably to follow up with an email saying, as we discussed today, I think that given the results, this instrument is all right, or this instrument should be replaced, or whatever the opinion is. Try not to give them, but sometimes there is no doubt that sometimes you know more about the instrument than the customer, and you can give your opinion of what they should be doing. But only if you're authorized to do so, and always keep those records. I think that's where we trip up most. Just the informal ones, not the formal ones. Amendments to reports. We all make mistakes, and occasionally we need to reissue or change or amend a report, a certificate that's already been sent out. When we do this, any change of information has to be clearly identified and, where appropriate, the reason for the change included in the report. Where appropriate is a great term. I can think of very few reasons why it wouldn't be appropriate. So pretty much identify what the change was and why it's been changed. Amendments after issue have to be made in as a further document or a data transfer, and it has to include the statement, amendment to report serial number, whatever. or an equivalent form of wording. So people need to realize this is an amendment to a previous report, and therefore the previous report should not be used, and this is the new one. Any amendments have to meet all the requirements of the standard and the regulators and the customer and your accreditation body. When it's necessary to issue a completely new report, that report shall be uniquely identified and shall contain a reference to the original that it replaces. So it should say report such and such, replacement for such and such report. That's generally what we're looking for. Again, my opinion is the amendment thing works under a very limited number of circumstances, whereas issuing a new report is, I think, fairly clear and is unlikely to cause any confusion with your customers. So be very much think about how to make sure that they understand that they have new data and they should be using it. This is the important thing. We don't want them using the old data. Complaints. So standard is that we have to have a complaints procedure. It has to be documented. It has to be publicly available. The process for the complaints procedure should be available to any interested party on request. We have to take responsibility for the receipt of the complaint, verifying the validity, evaluation of information, and decisions to address it. We have to acknowledge the complaint if we can, and provide progress reports, outcome, and the notice of closure. And we have to assign an independent person who was not directly involved in the activity subject to complaint to review, approve, or communicate the outcome. 17925 is only interested in laboratory activities, calibrations. So this only applies to complaints directly related to those areas. And it really just reflects, I think, the way modern complaint processes occur. So you probably have a complaints process and it probably is transparent, such as these are. I don't think many laboratories won't have this in place. Complaints is related to some things. Non-conforming work. If someone's complaining, maybe there's some non-conforming work there. Maybe we have to address some risks and opportunities. So maybe there's a risk that this will happen again, and we can do something about it. And there may be corrective action. We may need to go back and change this certificate or this and other certificates or our procedures to prevent the complaints, the subjects that caused the complaints to be happening again. So it feeds into a lot of other processes. Non-conforming work. So you have to have a procedure that you implement when any aspect of your activities or results don't conform to your own procedures or the customer requirements. An example, equipment or environmental conditions are out of their specified limits. You're monitoring your environment, you're checking your equipment, intermediate checks, or when it comes back from calibration, it's out of the specified limits, out of the acceptance criteria, in which case you should be looking at a non-conforming work issue. Results of monitoring, we talked about internal monitoring. They fail to meet the specified criteria. The non-conforming work, we need to deal with it. It relates to other things. Again, actions to address risks and opportunities. What's the risk of it happening again? And what corrective action should we be taking either to solve this problem or preventive action to stop it happening in future? There's quite a lot of words here, but it's quite important that we understand who is responsible, who has the authority for managing this non-conforming work. We take actions based on the risks, what we've accepted as the risk levels. Do we halt work? Do we repeat work? Do we withhold reports? Depending on the risk levels established. have to look at how significant the non-conforming work is, and we have to look at an impact analysis on previous results. So does the result of our intermediate check on our instrument mean that we have to review all of the previous certificates that have been issued using that instrument? We need to make a decision on the acceptability of the non-conforming work. Maybe it's out of specification, but maybe everything we've done within the uncertainties that we've allowed will still be fine. We have to tell our customer if necessary, and we have to recall the work, and we have to have responsibility for authorizing the resumption of work. So all of this needs to be managed. You need to have an external authority and responsibility. This is something a quality manager would generally do, but you shouldn't be doing it yourself for your own work in your own laboratory. We have to keep the records so that we can provide the evidence that we did this, what the work was, and what the actions were taken. If it might occur, or if there's doubt about whether we're following our system, our quality system, our procedures, we should implement the corrective action. It happens. Non-conforming work happens. Everybody makes mistakes, and everybody has at some point had to stop work or withdraw certificates or replace certificates because something has gone wrong. So the important thing is to deal with it when it happens, and obviously to minimize the risk of it happening. So previous versions of 17025 were written in the days of paper and pen and standalone computer systems. But the latest version actually has moved into the modern world. So you need to have access to the information and data, instructions and manuals to support your activities. If you have a laboratory information management system, a LIMS, it has to be validated, and any interfaces have to be validated. If it's a commercial system, that's fine. You don't need to interface the system, but you may have some specifically written interfaces to take data from one system to another system from your measuring system in there, and those need to be validated appropriately. If you make any changes, you need to authorize, document, and validate them. You have to make sure your LIMS is operated in a way that safeguards the integrity of the data. You have to prevent unauthorized access to look after the confidentiality and the integrity of the data, and provide safeguards against tampering or loss. Data transfers and, more importantly, calculations need to be checked in an appropriate and systematic manner. So you have to have a way of checking the data transfers. This is usually fairly trivial, and the calculations to make sure you're getting the right results. So this has to be done. And if this is being managed off-site, you need to make sure that it's all being done in accordance with the standard. So often, much of this belongs to your IT system. So your IT managers need to understand that they have some requirements under 17025. They have to understand that your assessor may need to talk to them about how they do this. And they need to make sure that they can provide those records for your assessor when that happens. Okay, we're on the final leg now, section 8. Management system requirements. So we've finished with the technical stuff. This is about management system. And you have to have a management system that meets the requirements of ISO 17025. It has to be documented. It has to be implemented. You need to keep records, and it needs to be maintained. So if you have certification to ISO 9001, then ISO 17025 considers that the requirements specified in 8.2 to 8.9, which we will talk about, have been met. You don't have to do anything else in theory. And this is option B. Option B is You rely on your ISO 9001 certification, and you don't have to have a specific management system that addresses 17025. Option A is that you have a specific management system addressing 17025 within the laboratory. This is the way it used to be done. So many of us who have labs of a older vintage have already set up a management system and a procedure as was required, and you can continue to use that. The new option B is very useful for laboratories that are already in ISO 9001 companies, particularly those that are in regulated environments. They find it much easier to implement the new system based on 9001's certification rather than having to write their own management system just for the laboratory. So somewhat illogically, but it does make some sense. We'll talk about option B first. So in option B, you're relying on your 9001 certification, but you have to demonstrate it is capable of supporting and demonstrating the consistent fulfillment of the requirements of clauses 4 to 7. So your 9001 needs to be making sure you're meeting the technical requirements. So you need to think carefully about the scope of internal audits. You need to make sure you're auditing in the laboratory against the requirements of 17025, not just 9001. And you need to think about the management review. 9001 management review can be a little bit of a coffee drinking session for senior management, whereas 17025 management review is a fairly intense day or so of reviewing data. So you need to make sure that somewhere in your 9001 management review, there is some consideration of the performance against the requirements of 17025. And I think if you read between the lines, what we're talking about is somebody providing a report on a more detailed review that's probably been done within the laboratory. I haven't really had a lot of exposure to option B laboratories. We have one or two, so I'm not entirely sure how this works out, but I'm sure your accreditation bodies will be able to help you to make sure that you're meeting those requirements if you go down that route.
John, you still with us? We cannot hear you. John? John, we cannot hear you. John, can you hear me, John? John. John, he has a problem, I think. Okay, I think John has technical problems. waiting for him to fix his own problems. But I would like to mention that tomorrow we will have 2 days workshop and risk assessments. Please, I put the link in the chat, and our instructors gonna be she's very professional, Alma Agofek. So please don't miss this very important training course for tomorrow, and join us at 9 o'clock exactly. I think everyone has the link. I put the link in the chat if you miss it. So please don't forget this. It's continual for what it's presented today, and but in more depth of risk management related to the quality management systems, with the exercises and some practical examples that Alma will present it to us tomorrow, hopefully. John, you are with us? You are back with us? John, still you are not with us? It looks that yeah, I got a message from John that he lost the connections. So be patient with us, please. Just I think he's coming, John. As I said, please, if you forget to put your details in the chatting box for certificate, please do it right away, because we will just, you know, get you the information for your certificate from the chatting box. Yes, John, you are with us again.
Hello, I'm back again. Sorry about that. I don't know quite what happened. I think my computer got excited by the sheer excitement
yes,
of
we
this
cannot
presentation.
rely on technology. Yes.
Okay, do you?
Okay, back to you, John.
Do you know where we were? Where were you when I lost you? Oh, hang on.
You
I
are
can't share
better
my
than
screen.
me, John. Yeah, you are better than me to know where.
Well, I don't know when. I know
But
when I
think
when
you
I
are
lost you.
about
I'm
to
not sure when
finish.
you
IP
lost me.
and type B management.
Type B management. Okay. We'll go back a little then. I think from where I thought I'd got to. Right. Okay. So hopefully you can hear and see me again. Option B relies on your 9001 certification, but you have to make sure that you are appropriately dealing with the requirements of clauses 4 to 7, the technical requirements of 17025. So you need to look at your internal audits and your management review to make sure that that's happening. Option A, you're going to have to establish within the laboratory a full set of management system documentation. Some of that can be references out to your corporate information, but you have to have a consistent set of documentation available to address 17025. So the documents, and again, I think we mentioned this before, documents are the instructions, they're the procedures, they're your processes and policies on how you're going to do your work. They can be hard copy or digital, they don't have to be paper. They can be online, they can be stored somewhere. All of that is possible as long as you meet the requirements. So these are your instructions, your documents. And you need to have a continual process to update them and improve them. They're not a one-off, unchangeable documentation. So you need to make sure that that's manageable, that you don't have too much bureaucracy involved in making these changes, because if those procedures can't be changed, then people will start to do things that are not according to procedure. I can guarantee you that will happen. I've seen it too many times. So you have to, as your laboratory management, you have to create, document, implement, and support policies and objectives that address consistent laboratory operations, competence, and impartiality. So you need a policy statement of the intentions and directions, and then you have a quality policy that provides the basis for the quality. That quality policy, rather, provides the basis for some quality objectives, and then you should be monitoring your performance against those quality objectives. You need the laboratory management to provide evidence of commitment to the development and implementation of the management system and continually improving its effectiveness. How do they do that? Involvements in things like management review, reviewing the procedures, signing them, those sort of things. We should see something to show that the laboratory management, whoever you've declared they are involved in this process, and they understand what's going on and they're committed to it. So this system, this documentation, management system documentation, needs to be linked, reference, included in the documentation. You don't have to have one giant document with everything written in it. Some bits could be paper, some bits could be online, some bits could be part of your company's main management system. It all has to be linked together, and it all has to be integrated so that it works together. That's the important thing. Anybody doing any work involving the laboratory activities, so your testing and calibration or sampling, need to have access to the parts of the system related to what they're doing. They don't have to have access to everything, but they need to have access to those parts that include the procedures for what they're doing and any other documentation. And these documents need to be under control. External documents and internal documents need to be controlled so that they are in some way issued and withdrawn, so that you can only get hold of the current documents unless you have a very good reason to get rid of the obsolete ones. And 8.3 is the next section, which talks about control management system documents. So your documents, and this is normal, this is routine, this is the same as 9001. The documents have to be uniquely identified. They have to have a revision number and changes identified, and they have to be approved for adequacy prior to issue, and the program has to be authorized. They have to be periodically reviewed and updated, and the current versions need to be available where you need them. You need to control distribution if necessary. Sometimes controlling distribution is simple because we often have these things online, but you need to make sure people aren't downloading and printing out documents, because that's when you can end up with issues with uncontrolled documents about. If you need to keep obsolete documents, it's controlled in a way to prevent unintended use. So you may want to keep obsolete documents. They shouldn't be available to people accidentally. Records. So documents are your instructions, how you do your work. The records are the things you produce doing your work, your evidence. And you need to create and retain these records. They have to be legible so that you can demonstrate fulfillment of the requirements of the document. And you need to control them. They need to be identified, stored, protected, backup, archived. You need to be able to retrieve them. And there will be some retention disposal rules for these records. Again, lots of this probably managed by your larger organization if you're part of a larger organization. So you just need to know what those rules are and reference them. You have to retain records for a period consistent with its contractual obligations. So this is one of those gray areas. How long do you keep records? Well, you need to agree that with your assessor if it's sufficient. You will have an opinion. You need to convince them that your opinion is correct, and they may or may not agree with you. You need to make sure that the records are, the access is consistent with the confidentiality commitments. So they have to be readily available, but they also have to be confidentially stored. So you need some login or some access restrictions. This is, of course, a balance that's frequently in place. We talked about technical records in 7.5. They're included in these records, but they have those additional requirements. And in 7.11, we talked about control of data and information management, which again is related to control of records, but that was more about the technical requirements on the storage and the retention rather than just the records themselves. You have to think about risks and opportunities. This is part of the modern approach to management systems. So you have to look at the risks and opportunities about the management system to ensure that it achieves its intended results. We have to look at opportunities to achieve the purpose and objectives. We need to prevent or reduce undesired impacts and potential failures in the laboratory activities. And we have to achieve improvement. So in the past, we would have talked about preventive and corrective actions, and these being appropriate for the issues that were perceived as happening. Now we're looking more at risks and opportunities, but still we're looking at continual improvement, preventive actions and corrective actions to try and ensure that we're achieving our objectives. So we have to look at the risks and opportunities associated with laboratory activities, risks for quality, risks for business, health and safety, which may be managed separately from this, and impartiality. We have to plan what actions will be taken to address those risks. And then we carry out the action within the management system. This should be integral to how we do our business. The risks should be identified, and that should feed the actions we're taking within our system. Those actions should be proportionate to the potential impact on the validity of laboratory results, or impartiality, or effectiveness of the laboratory, the operation. And we need to evaluate the effectiveness of actions taken. So risks, you're going to have, I think, 2 days with Alma over the next couple of days on risks. But what I will tell you is, I've worked on projects where risks were integral to how we did the project. And the projects worked well and the risks fed into that. Often we manage risks as an external thing. They have no real impact to what we're doing. And they become a little bit of an adjunct and a bit of a waste of time. So if you can, try and get the risks really integral to the way you run your projects, you will find the benefit. If you don't, then it won't really benefit you at all. It's very difficult to do it, but the benefit is really there when you do it properly. Improvement. You have to identify and select opportunities for improvement. How are you going to do that? Well, you're going to look at your procedures. You might do some Lean Six Sigma stuff. You may look at risk assessments. You will look at audits, and you will do management review for certain. So there may be opportunities for improvement. You can look at data and trend analysis, quality and control analysis. You can look at your corrective actions and see what's coming up there. And most important, you may have suggestions from personnel. All of these things will identify opportunities for improvement. Also, you should be seeking feedback, positive and negative, from customers. And then you should be using that, analyzing it and using it to improve the management system, laboratory activities and customer service. I have to say that in my experience in this region, it's very hard to get negative feedback from your customers. They'll all tell you how wonderful you are, They usually tell you you're too expensive, but other than that, it's very hard to get feedback. So you can't just send them surveys. You have to work at that a little bit harder. You need to give them the opportunity to tell you things without sounding too critical, I think. It's a cultural thing that the British are very good at giving you criticism. But I think within this culture, people are non-critical. And so you tend to just let lots of positive feedback, which is not really what you want from this activity. Corrective actions. Something's gone wrong. You've got a non-conformity. There is something that has to be done. The corrective action will take action to control it and correct it and address the consequences. This has to be done by an appropriate person. Somebody is authorized, somebody is independent of the activities that are going on. We want to take actions that prevent the non-conformity recurring. We don't just want to solve this problem, we want to stop it happening again. So we want to understand the root causes. We want to carry out the actions to stop the root causes reoccurring, and we want to assess the effectiveness of any action taken. This may affect our risks and opportunities. Maybe there's a risk we hadn't identified until we got into this non-conformity. We may need to change the management system. We may need to revise our procedures. The important thing is to retain records, to show that you had a non-conformity and to show that you had corrective actions. Those corrective actions, you want them to be appropriate to the effects of the non-conformities account. We don't want to demolish everything to deal with a very minor non-conformity. It should be targeted and effective. If you don't see a corrective action for a laboratory for a very, very long time, you start to get suspicious, because it's very easy to do these things without going through the process, to hide them. So there is a suspicion if you don't see non-conformities, if you don't see corrective actions. You look harder at laboratories when they're not showing you these things. So be open, be honest about it, because otherwise people will start to dig, and you don't necessarily want them digging, because you may have some things that are better left buried. Internal audits are probably the most important part of the management assessments within ISO 17005. They are one of the two things with management review where I have been on assessments and laboratories. We have been doing an assessment and the lead assessor has come to me and said, stop, we're leaving. There is no point continuing. They've not been doing their audits. They've not been doing their management review. We're not going to continue. So they're critical, absolutely critical. What do audits do? They evaluate if your management system complies with the standards 17025. If it complies with the requirements of the laboratory, and most importantly, is it being followed? So you need to establish an internal audit program. We'd expect internal audits at pre-planned intervals, at least a year, I think. I don't think it's written anywhere, but we'd expect you to visit each area, each laboratory at least once a year and look at defined scope and criteria. We need to communicate the results. It's very important that the management understand what's happened, what's going on in the laboratories if there are problems. We need to implement any appropriate corrective actions, and we need to retain records. Internal audits are very important because, one, the quality management people can assess whether people are following their procedures. They may not be following them because they don't understand them, because they haven't been properly communicated, because they're not possible to be followed. So there may be some follow-up for the quality people. It may not be that the laboratory is doing the wrong thing. It may be that the quality system haven't explained itself. They need to revise their procedures. Also, it keeps us honest. Someone comes into the laboratory and checks that you're really keeping up with your internal audits. You're really checking your intermediate checks, that you've been evaluating your equipment when it comes back from calibration, that you've been recalibrating equipment on your intervals. So what we're looking at is just somebody else coming in and checking. Things get forgotten, people get busy and things get delayed. Knowing that you've got an internal audit coming and ultimately knowing you have an assessor coming means that you have that in the back of your mind and you don't automatically worry about delivery and calibrations, but you're also keeping you honest on the quality front. So it's a very important part of the process. Management reviews. This is where you take all this information. You sit together, the laboratory management, the managers, the lab managers, the quality managers, customer service people, and you look at what you've done. Is the management system working? Are we delivering the quality to the policies and objectives that we set up? Are we really managing what we wanted to do? So has anything changed internally or externally? Are we meeting our objectives? Are our policies and procedures suitable? Have we followed up our previous management review? The internal audits, what's happened? Since the last management review, what internal audits results? Is there any patterns? Is there any issues that we need to deal with? Corrective actions, assessments by external bodies. What else? Changes in the volume and type of work or in the range of laboratory activities. We might be doing more work in some areas. We may have a new scope. There may be other things happening. Feedback from the customers and personnel. Any complaints? Any improvements and how effective have they been? Do we have enough resources? What are our identified risks? What are we doing about them? Have we been doing our validity of results? So internal checking, but also have we been doing our proficiency testing and ILCs? Anything else? Monitoring activities and training. So we're looking at the whole management system as a whole with all of the senior people there, and we're going through the data in some detail to understand if this is really working for us. And what are the outputs from this? This is a very minimal set, but you should be looking at some actions and decisions on how to manage the effectiveness of the management system, what processes need to be changed, what improvements there need to be, if we need to change the resources, and any other need for change. This is the list in the standard, but it's very much a minimal set of what you should be looking at producing from the management review. And that's everything I have to say. It's a little bit later than I was intending because I went offline for a few minutes there. And hang on. If only I can find out how, I will stop sharing my screen. So thank you. If anyone has any questions, I am open to at least discussing them, even if I don't know the answers. Some of the questions we had earlier were a little complicated. And also, please do go away and read the standard and get involved in internal audits, observing, doing assessments for your accreditation bodies, because this is how you will learn. Not listening to me for 3 hours. This will have all washed over you, I'm sure. So does anyone have any questions?
John, first, thank you very much for this very interesting presentations with a lot of informations and example. Really, you are explaining the requirement of 17025 in a very simple way. I've been in, this course before, but from your point of view, you are explaining your experience and putting your experience in fulfilling this requirements. We do have one question before we go to Dr. Arab. Actually, to give him the chance to answer questions. I got in chatting, and I put it in the. Can I share this if it's possible? I will share the questions. Just can you see my sharing?
Not yet.
what's the reason? Okay, I can read it to you, John, if I could. It's coming from Mr. Muhammad Munir. He's from ionizing radiation, by the way. It looked to me like this. That assume we need to recalibrate our gamma spectrometers by using reference material, CS 137 concentrations, 50 kilograms at 3 sigma confidence level, 99.97, and our result of recalibration recorded. And he is putting that. John, you can go to the chatting and you can also follow with me in the chattings. Okay, recording in CS 137 concentrations, sigma. Let's go to the can be considerate. The recalibration is acceptable and issue the certificate, or should we need to do the correction factor? I think it's clear. Even he is putting more data, and he's coming from the ionizing radiations technical committees. And by the way, we have expert also, Dr. Arib. He is an expert in ionizing radiations. John, he can help you also in this. Please, John, if you would like to comment.
What I was going to say is I am not an expert in ionizing radiation, so I'm very, very reluctant to answer that question at all. But looking at the figures,
I will invite
I would say no.
Dr. Arib.
But let's ask an expert.
Yes, Arib. Please go ahead. Dr. Arib.
Yeah, this is actually, it doesn't concern the ionizing radiation. This is spectrometry. So I don't know if there is anyone specialized in spectrometry. Yeah.
But I think Dr. Mahanna, the person who asked the question is coming from ionizing radiation, because he's talking about, you know. But it's really, you know, it's talking about, you know, recalibration factor. It has to be considered. I think you have highlighted this, John.
Oh, there's a lot of things going on here, I suspect. One is, which are the important things here? Is it the value that's important, or is it the uncertainty, which I'm guessing what the plus or minus is? So if you have a acceptance criteria, which should be established, if this meets the acceptance criteria, then that's fine and you can use it. If it doesn't meet the acceptance criteria, then you have a non-conformity and you need to deal with it through your non-conformity process. From that point of view, that's how you would deal with the 17025 aspects of this. But correction factors, again, that's up to you. How it depends on how you deal with your, what I'm guessing is a non-conformity because it's not meeting the requirements.
So, Muhammad Munir, are you happy with the answer?
Not very clear, because I need, because you know the interface between the level of concentration between the standard or reference material and the measurement in the lab. And the lowest of dynamic, it is counteract between the interference, but from above it is very far. It is considered as accepted recalibration, or should be put correction factor for our system?
This is the technical issue which I'm not qualified to answer.
The consider as an example, I analyzed one sample and our reference our accredited level or standard level for my company, you can say, or my country, you can say 50. And the result, it was coming 48 plus minus 2. And the standard is 50 plus minus 2. That means there is from the lowest domain, it is okay, but from upper domain, it's not okay. Can I accept it or not?
Mr. Muhammad,
This just
I-
as an example and the practical example for more explain for our
Yeah,
colleague.
it isn't a 725 issue though. I don't think this is to do with that. If you have requirements and it doesn't meet the requirements, then you have a non-conformity and you need to action on it. But whether or not this particular example can be accepted, I couldn't tell you. You need to have an expert to tell you that.
Okay, thank you very much. No problem. Thank you.
Actually, if you look at the reference material, it has a concentration of 50 plus or minus 2 becquerel per kilogram, but you measured actually 47 plus or minus 1.5. So if you look at the uncertainty levels, the two errors bars may not, be consistent. In that case, you have to consider a recalibration because both values are not consistent, taking into account the uncertainty. Yeah, this is the
Okay.
because if it was 48 plus or minus 2, then you can consider that you are actually measuring the concentration within the uncertainty, and then you don't need to recalibrate it. But in this case, if you consider 50 plus or minus 2, so the lower value is 48. For the measured value is 47 plus 1.5. It's 48.5. So you have what you call
interference between two.
Interference. Yeah. Then it's okay.
But from one side, not from both sides.
It's okay, but whenever you get the one side, then taking into account the uncertainty, you can consider that you are within the specifications. Yeah.
Okay, thank you very much. Thank you.
I believe Dr. Christos is going to give us a talk on conformity assessment at some point. So maybe he won't like me for this, but maybe you could bring this up with him.
Yes, Muhammad, can I know where you come from?
I am
Muhammad
from
Munir.
Syria.
Okay.
But now I am working in Environment Agency Abu Dhabi now, in Abu Dhabi.
I see.